colleague Jasvir Nagra. We're here from Google's Applied Security team. The Applied Security team, we work on improving programming languages, compilers, and other software development tools to make it easier to write robust and secure programs.
So what we're going to be talking about today is the security tools that every security engineer should have in his or her toolbox in order to bolt on new security policies onto existing legacy code. We'll be exemplifying this using our project Kaha, which allows you to replace the browser's same origin policy with new policies that control what code in a browser can and cannot do.
Since you guys are from OWASP, I'm sure you understand the same origin policy, but just to recap, the same origin policy assumes that all the code running in the browser for a particular site is vetted from or produced by that organization. So the user sees the domain name in the URL bar. Because all the code running in that site comes from that organization, they can make an informed decision to trust that site with their data.
So of course, with social websites, this isn't how social websites work. The social websites include third-party content into their domain. But users nevertheless hold the social networking site itself responsible for the data that users end up sharing. So as a social networking site, as a social website, what you would like to do is place bounds on the authority, on the amount of power that this third-party content that you cause to be executed has, and what it can do with the data that is being collected.
So that's the first problem. The first problem is that the security policy built into the browser isn't quite necessarily what you want. But there's another problem. Even if you could put whatever security policy into the browser you want, even if you could get the browsers to implement just the security policy you want, it's not going to stay the security policy you want over time. So when a social network is small, it's a small target. There's very little economic incentive for third-party developers to try to exploit it because there isn't a lot of valuable user data there. And social networks need to take advantage of this when they're small. They let web application third-party developers experiment and try and figure out what are really useful, what are the really interesting applications that work for their particular audience. By the time they get bigger, though, they have to rethink that decision. When a social network gets big, it's now a big target. The data that it's protecting is more valuable. They can't trust all the third-party developers anymore. And so they need to roll back some of the authority that they've granted. But they've already got this body of legacy third-party code written assuming a fairly permissive model.
So there's two problems that we're talking about that same domain policies bring about. The first is the policy, the security policy that social networking sites need is a different one from the one that is baked into browsers. That's the first problem. The second problem is that the security policy that you require changes over time as your threats change. Nevertheless, the legacy code that you have cannot change that quickly, and you need to be able to adapt your security policy without breaking the legacy code that you've ended up accumulating.
So the solution that we're proposing to both of these problems is virtualization. So when you virtualize, you're taking the APIs that legacy code was written to, and you're recasting them. So you're preserving the same APIs, the same semantic assumptions that legacy code makes, but you're changing the amount of real authority that you expose. So instead of exposing the entire network, you might proxy it to expose a subset of the network to untrusted code. You might do the same with a document. Instead of exposing an entire document, you expose a portion of it.
So the bad guy, the villain in our entire story, which will become clear as we proceed through this presentation, is ambient authority. And what I mean by authority is the ability for code to affect the browser's state. So for code to be able to change some state in the browser. An ambient authority is authority that is available irrespective of how code comes to execute. Now, with same origin policy, what the same origin policy means is that provided you know what the domain of a piece of code is, what the domain this piece of code was fetched from is, you know everything that is needed to decide how much authority this piece of code has. This code has, that amount of authority is ambiently available to all code from that domain.
I apologize if this is a bit of an eye chart. Don't worry if you can't read all of this. These are just examples of APIs that are ambiently available to web applications. So for example, a web application can assign top location to navigate a frame or navigate within a frame. They can use window.getComputedStyle to try and understand the layout and styling of a page. They can, of course, load images. All of these things on the top are ambiently available. The things on the bottom are bucketed by domain. But all of these had unintended consequences. So you can see that if I can create an image and attach an on-error handler, suddenly I can scan your local network. I can use window.getComputedStyle to mine history information. I can use assign top.location to top.location to load a new document, maybe one that spoofs the page that was embedding me, and now I can try and trick the user into giving me their password.
So one way of if you look at, one way of looking at particular problems is to step back and see where general problems arise. Now, you are all already familiar with the OWASP top 10 list. What you will probably realize if you look over this list and compare it to the OWASP top 10, you'll realize that 4 or 5 of the top 10 list are either directly caused by or made worse by the ambient authority that browsers make available. And so what's the social networking site to do? What is it that it can do to mitigate this particular problem? Well, there's several things that it can do. One thing it can do is to introduce new tools, new APIs. It can introduce new tools and encourage all of its third-party code developers to adopt these new tools and to use them. The downside here is that you must firstly motivate all of your third-party code developers to use these tools, and then you also need to police all of the code that is being generated to ensure that the new tools are being used and not the vulnerable old ones. And that's difficult to do because it's hard to get a large group of people motivated to use a new set of tools.
And to give you an idea of the scope of this problem, Facebook has over 500,000 third-party apps. A lot of them are probably infrequently used, but that's a huge developer community by any means to motivate. You could also try and reach that developer community, and instead of having them use new tools, try to improve existing tools. Maybe give them opt-in options, which subtly change the semantics of things to be slightly better. PHP magic quotes, ECMAScript 5 strict mode are examples of these kind of opt-in things. You're still trying to motivate a large group, but you don't always have to wait for the latest browsers to become to reach large market share.
Another thing you can do is, so clearly there's a problem with motivating a large group of users. What you are able to do for some particular kinds of problems is you may be able to introduce a new tool which only a small number of developers have to adopt before a large number of users benefit. So examples are authors of popular JavaScript libraries or browser vendors. If you're able to convince them to use a new tool, as a result, any browser user or any library user may end up benefiting. Now, this only works for particular problems, and you also have to really wait until browsers and libraries catch up and release all of this code.
But the way to be really responsive to emerging security threats and to current security threats is to get in a sweet spot. instead of trying to motivate a large group and instead of trying to introduce new tools and waiting for new browsers to come out, you can try and target a small group and improve existing tools. Virtualization does this. Virtualization is kind of a meta tool. You're using the existing tools to improve the security properties of existing tools.
So virtualization is the general method that we are advocating. We're going to exemplify it, as I say. We used it in our project, Kaha, to virtualize the browser. Now, the virtualized browser allows you to include, well, allows social networking sites to include content that they don't necessarily trust, and they can do so without using browser plugins. Now, this is important because you need to be able to, well, we needed to be able to target a large number of different browsers. So we target all browsers from IE6 onwards, Firefox 2 onwards. And the way we do this is we introduce a software interposition layer between the real authority that browsers hold and the virtual authority that we end up granting to third-party code. And the way in which we expose this authority is in the choice and implementation of the virtual APIs that we expose to third-party code. This way, when a new threat arises, and you've heard a large number of different threats today, and I'm sure you're going to hear about more of them tomorrow, when a new threat arises, what you're able to do is re-implement that particular API, so maintain API, but change the amount of authority that that API exposes to third-party code.
So I'm going to walk through some examples of common APIs available to web applications and explain some of the tools that you can use to virtualize these and hopefully give you a sense of the range of interesting security policies that you could implement. One of the a very commonly used and well understood browser API is the date object. It just gives you access to the system clock. It's not without its sharp edges. The date object is used in almost every single timing attack out there, but it's well documented. Its security consequences are well understood. So as a first cut at our security policy, maybe we'll just allow untrusted code access to date. And we do that by not virtualizing. We just allow access to that object and unfiltered. At the other end of the spectrum is ActiveX. ActiveX is an extension mechanism. And since it's an extension mechanism, the exact amount of authority that it provides is context dependent. It's poorly understood. It's poorly documented. It's really very hard to predict what an application can do when it has access to ActiveX, except to say that it's probably a lot more than you want it to do. So as a first cut, we're just going to disallow access to ActiveX. And we do that by simply not allowing untrusted code access to it. Then there's XML HTTP request, which is a very widely used API. It's well documented and well understood. We might want to attenuate that. It provides access to the networks. We might want to allow it access to some URLs and not others. If we're lying to the third-party code and telling them that they're actually running in a different domain than they think they are, we may want to maintain that illusion here. But there's a problem with XML HTTP request. It's not implemented on all browsers. And where it's not implemented, web applications tend to fall back to using ActiveX, which we've already decided we don't want to allow access to. So we don't want to break all the applications that use XML HTTP request where it's available in ActiveX otherwise. So what we do is we create a power box. The power box contains a lot of real authority and just doles it out in small doses. So our power box uses XML HTTP request where it's available. Otherwise, it uses ActiveX to create an XML HTTP request-like object. Then we stick a proxy in front of that. And so now we can filter access to the network, possibly allowing it to access these URLs and not these URLs, maybe channel some URLs through a real proxy server so that we can reason about which part of the URL space